I've presented. Okay, now, okay, I hope you can see my slide. Now, we have come to the second part of our last part for continuous probability distribution. As what we have in the discrete probability distribution, we have also the cumulative distribution function. Now, the same for the what we call continuous random variable, we have also the cumulative distribution function for continuous. Now, if we flash back what we have for our discrete random variable x, denoted as fx, okay? So this particular fx, okay, to find the probability of x for certain value of x, that particular certain value of x, okay, here, is given by the summation of all the function of t, where t takes the value of x, okay? And we know that the condition for this particular fx should fulfill, it's either 0 until 1. That will be the probability value. And the cumulative probability distribution function will be fx is less than or equal to fy. Okay, this is what we have done in the previous part. Okay, and the range for the random variable x for discrete as follows. Okay, we have seen this part last time, so let us see how these particular things reflect for continuous random variable. Okay, so for cumulative distribution function for continuous random variable x, okay, hold on, where is my, hold on. Okay, I got so many wire on my table. Okay, now this almost similar to what we have in our discrete random variable. It's just the difference that we have the this part. Okay, we have this particular integration part. Okay, and still we are talking about the function of t, and in this case we are going to differentiate or integrate with respect to t, where x takes any values from negative infinity to positive infinity. Okay, so that will be the cumulative distribution function for continuous random variable. Okay, so that will be continuous random variable. So what else should you understand? Let fx be the distribution function for continuous random variable. So we know that this fx is what we call the distribution function for x. Then, in order to find the fx, okay, so what is the fx? The probability, the density function. Okay, the density function. Okay, to find that particular density function, we have to differentiate. So this is how we differentiate. Differentiate the function of fx with respect to x, or the sign can be, the symbol can be, is either dy, last time dy dx, or sometimes we call it as y prime. Now we are talking about fx. Since we are talking about fx, so to differentiate fx, this would be dfx with respect to x, or simply we can write as f prime x. Okay, so that's how we find the density function for this particular distribution function. Okay, so this will be the things that you need to understand about the continuous random variable. Let us look at one example, how to do this. Okay, now if x has the probability density, now we are talking probability density function, small f x. So this is density function where for x greater than 0, the density function is given by k e negative 3x, and elsewhere is equal to 0. If I have the line here, if 0 is here, is greater than 0 is given by this function, and elsewhere means that this part is what we call equal to 0. Here is KE3x negative. Okay, so that's how we understand this particular function. Okay, now you need to find K. Okay, you need to find K. Remember back class how to find K? And we are talking about density, probability density function. We are talking about the what we call the condition for this particular density function here. Okay, when you integrate the function with respect to x for certain values, you will get 1. Okay, so it's just the same of what we are looking for here. Okay, so to find your K, okay, so to find your K, you will integrate the given function, density function, that will be K e negative 3 with respect to x from what? You are given only from 0. But 0 until what? We know that as we go on, the value here will be positive infinity. So here it will be infinity. Okay, so take out the K just to simplify your calculation. Okay, because we know that K is just a constant. It will be just a value. So we solve for this one. Integrate e to the power of negative 3x. You will get what? E to the power of negative 3x. You will get negative 3x. Differentiate, you will get negative 3. That negative 3 become your denominator, negative 3. And you need to find the definite value for this particular integration from 0 until infinity. Okay, so d per dx for 3x. Okay, for those who cannot remember, after this, go back and find how you can differentiate exponent, integrate exponents simply. Okay, usually we are not going to give you a complicated calculation for the exponent part. So if we take into the value to the function, you will get what? So for the first one, it will be e to the power of negative 3 infinity. You got infinity, multiply with 3, it's still infinity. Multiply with negative, it's negative infinity. Okay, over negative 3. Big value divide by, negative infinity, you will get what? 0 or 1 class? 0 or infinity? Are you all with me, class?
0.
Okay.
0.
Okay, thank you. So negative 3 here. Can you solve this? This should be equal to 1, should be equal to 1, should be equal to 1. So this will be, let me change the color. So this will be 0. And this will be what? So K, negative, negative, negative. So you got positive. K what?
1 over negative 1 over 3.
1 over 3, yes. Equal to 1. So K would be equal to 3, right? So that will be your value for K. Having said that you have the K value, now you need to find the Fx. What is Fx? This now is the probability function. Distribution function, sorry. The distribution function for X. Now, we are looking for number 2, Roman. What is Fx? Okay, remember back, what is Fx? Okay, given that you have this, this is your density function for your Fx. Now you reverse back. Okay, reverse to get the Fx. Just now we begin with Fx, right? Okay. we begin with fx, okay? Then we find the probability that we prove that the given probability density function. Now we're trying to find the probability function, distribution function for this particular value. So how do we find this? Okay, so since we have our condition here, that will be, remember that our value from negative infinity to positive infinity or infinity only until you get the value involved in your operation, that would be 0. Okay, so the density function, the distribution function will be taking from this negative infinity until infinity. So for this one, okay, how are we going to do that? So we are going to continue with the looking for x is less than or equal to 0. Okay, for x less than or equal to 0, fx is given by, okay, greater than 0 is ke negative 3x. Less than 0 is 0. So less than 0 is 0. Integrate with respect to x. And this one is from negative infinity to 0. Okay. Less than or equal to 0. Okay, negative infinity to, okay, let me check my notes. Okay, so this one definitely will give you 0, right? Because you have the function 0. Now you have then for x greater than 0, okay, so that will be this one. So this will be fx given by integration from negative infinity to 0. Okay, that will be 0 dx plus from 0 until x. And for this one, you will get kex, that will be 3 e to the power of negative 3x dx. Okay. Now, from negative infinity to 0, 0 to x. Okay. So in this case, class, what did I do wrong here? To find fx, it will be in terms of t. Sorry, class. So this one is actually for t. I made a mistake here. Let me change with red pen. My throat is really killing me. I wish I can get a good cough. Okay, so this should be t. This one t, this one t is t, then this is t. And really sorry class, this one should be 0. This one should be x. Because why class? Because we are integrating from negative infinity to x value here. Okay, so it should be x. Sorry for making mistake here. So from negative infinity to x, okay, that will be given by 0. And then from for the second part, that will be that involve the function. So we are still looking for negative infinity until 0 plus 0 until x. Okay, considering the two function for x equal to 0. And this one definitely will give you 0. And this one will give you this will be 3 e to the power of negative 3t over negative 3, and you get 0 until x. Okay, so this one will give you what class? Can someone replace? So this will give you 3 e negative 3x over negative 3 minus e negative 0 multiplied with 3, you get 0 over negative 3. Can you simplify? You get what class? So if we cancel out 3 here, so we take out negative 3, 1 over negative 3, so you will get what? E negative 3x plus 1. Am I correct, class? You get this for number 2. Okay. So we are looking for the distribution function for continuous random variable. Remember back class, for continuous random variable, did I discuss last time continuous random variable? Not in this part. Okay, never mind. Okay, so you will have here, okay, you have got your function here and you have got your function here, and how you can write your distribution function for your continuous random variable, you will be given by fx is equal to, since we are trying to find the distribution function for this particular density function, almost similar of what we have here, but then we are looking for capital Fx here. And taking into account this particular answer that you got, okay, so you will have e to the power of negative 3x plus 1. Plus 1 is here, okay, and this one is for what? Greater than 0, x greater than 0, and 0 for x less than or equal to 0. Okay, so this is your distribution function for your x random variable, continuous random variable. Now, our aim here is to find, okay, our aim in order to find this is to find the fx from negative infinity to infinity. Okay, from negative infinity to x, sorry, to x. Yx, here class, from negative infinity to x. Okay, so we follow what is being given in the cumulative distribution function. Even though the condition is from negative infinity to infinity, our intention is just to find the negative infinity to x in order to get the what we call distribution function. This is distribution function. Okay, now once you have got your distribution function, okay, we can use our distribution function to find our probability value. Okay, now you need to find the probability value for x greater than or equal to 0.5 but less than 1. Okay, so by using this particular answer, you can answer for number 3. So that will be, let me change the pen color. So you are looking for px, sorry, Everyone is so quiet. I hope everyone
Ma'am,
is with me. Yeah,
the K is not 1/3.
sekejap sekejap. 0.5, 1. Which one K? K is 3, right? K is K multiplied with 1 over 3 is K over 3. I would like to find what is K. So K is 3 multiplied with 1. K is 3, right? That's why we have 3 here. Okay, that's why we have 3 here. Because 3 here. Okay, is it okay? Okay.
Doctor, is it supposed to have negative before the exponential?
Negative. No negative here. Because negative is already taken into this part. Remember, we differentiate
No, I mean the right side,
right side.
right
Which one?
portion, the right lower portion.
Uh, okay, which one? Number 2 Roman or 1 Roman?
Number two Roman.
2 Roman. Which line? The red.
Uh, the
This
red
one.
line.
Is it this one?
Yeah. Is it
Okay.
to have negative before the exponential?
No, negative here because I have already taken negative for 3 here. I already took the negative. Okay, if I differentiate e negative 3x to the power of with respect to x, I will get e negative 3x. That will be my first integration. Since I have negative 3x, I can differentiate, it will be negative 3. So this is the integration answer for this part. Okay, so this negative is this negative. So the negative for exponent is actually here because the coefficient for 3x is negative here. So negative I took here. So
Uh,
that's why it just
yeah, how
appear here.
about the final answer there?
The final answer, negative multiply with negative, you got positive, right?
Yes, and
Okay.
um, the X.
So this one is, oh, you mean here, right? You mean here, okay. E negative here, right?
Yeah.
Okay, just tell me I missed the negative part, okay? So if that's so, it will be 1 minus e to the power of negative, my goodness, okay, negative 3x, okay? Okay, thank you for correcting me. Okay, so this one would be, then this one would be, let me rewrite again everything. So 1 minus e negative 3x. Okay, thank you for correcting me. Okay, now we can start answering the question of finding the probability value. Okay, now for this one, it's just almost similar of what we have in discrete random variable. So we can find the probability value by using the cumulative. So this one is the cumulative one. Okay, so begin with the larger value. So F1 minus F0.5. And then taking into the value of this one, so you will have 1 minus e to the power of negative 3 minus 1 minus e to the power of negative 3, 0.5. Okay, can you find the answer? What is the answer? So if I simplify, this will be 1 minus 1 minus e minus 3 minus minus plus e minus uh, 3 minus 1.5. Okay, so what did you get here? I got 0.5567. Anyone got a different answer? Anyone got different answer? Am I correct? Okay.
Ya, Doktor.
Okay, thank you very much for verifying. Okay, very quick for one exercise, then we will finish our expectation, expected value, variance, and standard deviation. Very simple. Okay. Now, let us see exercise number 2. Okay, just to have to get the feeling of how to understand how the continuous random variable can be solved for the probability density function, as well as finding the cumulative distribution function and the probability value. Okay, so for this particular exercise number 2, okay, you are given this probability density function. Find the cumulative distribution function fx. This is the one that we have just did for question number 2, Roman. If you can try on your own, okay, while I'm doing the same. Let me change the pen. Okay. To find the cumulative density function, cumulative distribution function, it would be from negative infinity to x. Okay. So first, for x less than 0, so you will get fx equal to, okay, less than 0 means that you take this one. So 0 dt from negative infinity to 0. Okay. So 0 to, okay. So definitely you will get 0 for x between 0 until 2. So your fx will be from negative infinity to 0, and then you got 0 dt plus from 0 until x, you got the one given in your function, 3 over 8 x squared dt, sorry. So should be t. Okay, then we know this is 0. Then we solve for the second part. So that would be 3 over 8 t cube over cube from 0 to x. So this is given by what? 3 over 8 x cube over 3, okay, minus 0. Okay, so you will get x cube over 8. Okay, am I correct? Now, less than 0, from 0 until 2, but for greater than 0, you have to find the last part for x greater than 0. So this will be fx. Okay, so fx, again we will going to repeat the same process, but now greater than 0. So we are beginning from a negative infinity to 0. That will be for 0 dt plus from 0 until the given one is 2. So 2 here, and the function is 3 over 8 x squared dt, should be t here, plus the last part, okay, greater than 0. Okay, the confounded one is here, and otherwise is less than 0 and greater than 0. So for greater than 0, 0 dt for 2 until x. Okay, so please look at the given what we call from negative infinity to 0, 0 to 2, 2 to x for x greater than 0. So we start one by one. since we are looking for cumulative, right? That's why we try to find out one by one for each of the terms given. Now, let us continue. If I simplify this, since we have limited time, so let's say I simplify this, you should get this as what? 3 over 8. You will get 3 over 8, and then you got 3 cubed over 3 from 0 until 2, and from 0 until 2, you will get 3 over 8, 8 over 3 minus 0. Okay, so you will get 1. Am I correct? So you will get 1. So if we simplify the answer in terms of cumulative distribution, okay, you will get your fx. So class, please know the boundary. So the fx is given by, you have 3 terms. One is 0, where this is applied for x less than 0. Second is x cubed over 8. That will be for x between 0 and 2. And the last part is 1 for x greater than, is it x greater than 2 or x greater than 1? Sorry, class here is greater than 2. The one mistake will be, since we stop at 2. So that's why we take for x greater than 2. So x greater than 2. Okay, so x greater than 2. Okay, so that will be the cumulative distribution function for x continuous random variable. And you need to find what will be the px between 1 and 2. Okay, so from these 3 conditions that you have, you can find the probability. So this will be F2 minus F1. So F2, okay, so in this case, this will be applying for this particular condition or cumulative distribution function for x cubed over 8. So that will be 2 to the power of 3 over 8 minus 1 to the power of 3 over 8. So you will get 7 over 8 as your answer. Okay, so that would be the probability value for x is between 1 and 2. Okay, class, are you all okay?
Doctor, I got a question.
Yes.
Yes, as second situation, when we get x to integration, why the second integration is from 0 to x? Why not from x to 2?
The second integration?
Yes.
Yeah, because why? In this case, remember we are talking about cumulative. So in this case, for the second one, we were going to stop at x because we are trying to find the cumulative distribution function for this particular condition value from 0 until 2. Okay, but you see, how can I explain to you? Okay, we begin with the first cumulative distribution function where it involves only less than 0. Now, less than 0, then we know that we have the second condition is 0 until 2. But for 0 until 2, okay, we are going to stop at x because we have this, following this condition. Okay, see, for the value negative infinity to alpha, negative infinity to infinity, so we are going to get negative infinity to x. Okay, so I will have to say you need time to digest this, okay? So this is how we going to, extract one by one, because we are talking about cumulative. So from less than 0, what if from 0 until 2? What if it's greater than 2? Okay, so in this case, we are going to stop at x. Okay, but now here, for 2, we are going to stop also at x. If we get from 2 to x, because imagining that we are talking from certain value to x, certain value to x, let's say 2 to x. Okay, so this x will be the kind of the boundary for this particular function, because we are looking for the cumulative distribution, okay, for this continuous random variable. It's okay if you don't understand, just follow the step first. Later on, once you have understood the whole process, I think the understanding will come why we stop at x. Okay, but not here. Here also is actually the first one is for x, beginning from x, right? 0 until x. I believe this one is also from 0 until x. Sorry, class. Okay. But since we are talking about integration of 0, it will just 0. So don't bother lah. Okay. Okay. I'll just keep this with you for a while. I want you to try the example 4 later on. If you don't understand, we will just discuss later on. I would like to finish this particular last part. Okay. In within maybe 10 minutes, we are going to see how we can find the expected value for x if it is coming from continuous random variable. Okay, now as what we have in our discrete random variable last time, if x is discrete, we can find the expected value of x. Okay, that will be the mean. Okay, and we can find the variance of x by finding the x squared minus x, the whole thing squared. So we are going to repeat this again. Okay, but now following the continuous random variable way. Okay, so if you can compare between the discrete and continuous, so this is how we find the mean for discrete random variable. We have the distribution function. Okay, we multiply each of the distribution function with the particular x. But now, if we have for continuous random variable, also we are talking about the integration, and the integration of this particular fx, we multiply by x. That's it. Just multiply by x to the function involved. Then integrate with respect to x. Okay, so that will be the simplest way of how to find the mean of x, mean of the continuous random variable. What about finding the variance? Also the same. Finding the variance, find the ex squared, find the ex and square them, minus or subtract the value, you can find the variance of x. Or the standard deviation, you just square root the value, you got the standard deviation of your continuous random variable. Okay, the same properties apply. Okay, if you have a constant, you need to find the mean of a constant, it will give you only the constant value as your mean. If you have x with a coefficient in front, so you can take out the coefficient, so it will just simply the coefficient multiply with the expectation of x. The same goes to this one and this one. Okay, it's just the same as what we have discussed in the discrete distribution, a discrete random variable. The same goes to the property of variance. Okay, for coefficient, when you take out, you square them. Okay, the same goes to the third condition. Let us look at the first example. Let x be a continuous random variable with the given with the following probability density function. So you are given the density function. as for x greater than or equal to 0 but less than or equal to 2 is given by this function. Otherwise of the value, it will be 0. Okay, you need to find the expected value of x or the mean of x. How we find this? Okay, now as usual, you will have to find the fx. So you are given the probability density function. You need to find the fx. Okay, you cannot work from the density function. Am I missing the first example? Example 4. Okay. Now, example 5. Okay. For this one, how we are going to do it? So for A, we are going to find expected value of x, where x is the continuous random variable. So we know that for expectation of x, it will be multiplying the given function with x. So this is the x that you need to multiply, and you need multiply with the 3 over 4x, 2 minus x, okay, with respect to x, and it will take values from 0 until 2. Okay, now in order to find this, you can simplify. Okay, simplify as simplest way, you can take out the coefficient value. So this will be 3 over 4 from 0 until 2, and you will get x multiplied with x multiplied with 2. You get 2x squared minus x multiplied with x multiplied with x, x cubed dx. Okay, so solve for this one. You will have 3 over 4. Then you get 2x cubed over 3 minus x to the power of 4 over 4 from 0 until 2. Okay, so if you solve this, okay, you will get 3 over 4. You will get 16 over 3 minus 16 over 4 minus 0. Okay, so you will get 1. Just check class, am I correct? Expected value of x is 1. Is it correct? 1, right? So you got 1. So you need to find what is variance of x. In order to find the variance of x, you need to find ex squared minus ex, the whole thing squared. So ex, you got this one. You need to find ex squared. So solve for ex squared. So for ex squared, okay, how do you get? So ex squared will be from 0 until 2. So you will get x squared multiplied with 3 over 4 x, 2 minus x with respect to x. Simplify everything, you will get 3 over 4 from 0 until 2. So you will get 2x what? Cube minus x to the power of 4. Integrate with respect to x, you will get 3 over 4, 2x to the power of 4, divide by 4, x to the power of 5, divide by 5. From 0 until 2. Can you find the answer, class? Can someone tell me what is the answer?
$1.2.
Yes, correct. The last part will be 6 over 5. That will be 1.2. Okay. So in order to find the variant x, it will be 1.2 minus 1 squared, that would be 1. So you will get 0.2 as your answer. What about the standard deviation in extra? Standard deviation, or I just use the symbol here. So what is your answer? It's the square root of 0.2, right? It will be what? Is it 0.4472? Is it correct?
Yes.
Is it correct? Correct, right? Okay. So this is how we find the variance, the standard deviation, as well as the mean. So this is the mean, right? Okay, so next time, if you're given any probability density function, you can straight away find the mean, variance, and standard deviation for the given function. Okay, so for the exercise, since it's already 10:29, so I'll just give you time to have